Assalamualaikum warahmatullahi wabarakatuh. My name is Faiza Imania Putri. I'm from Group 6. So in this video, me and my teammates will present our project with the title Optimizing Carbon Reduction Measurement. So firstly, our project purpose is to improve the current system of low carbon competition that conducted by MBIP before. And before go to the implementation step, to minimize mistakes occur in the implementation phase or coding phase, all of this diagram that we created in this project act as a communication bridge between creator and viewer or stakeholder and clients. Yeah. So firstly, we have the architecture model of this system, and it contains three components interface here. Five component interface: leaderboard view, profile view, analysis view, announcement view, and carbon input view. And we also have three controller, here, which is leaderboard controller, carbon analysis controller, and update data controller. So it acts as an intermediary to connect the interface with the model. And we have a model here. So we have user model and carbon footprint model. So it holds the information of these instances here. Like user model, it holds the information for user, and then carbon footprint, it holds the information for carbon footprint. And we can also see the connection here. Leaderboard controller interact with the leaderboard instances, like it connect to the leaderboard view, and then announcement view, because it will display here for the leaderboard and user model. And for the carbon analysis controller, it connect with the carbon input view, and then analysis view, and carbon footprint model. And then this is for the update data with the carbon input view and carbon footprint model. And next we go to the use case diagram. So we have three models here: registration and login module, carbon consumption calculation, managing and troubleshoot module. And we have three actors here: participants, MBIP system, and MBIP staff or admin. And so firstly, a participant need to register, and after that they must log in to get in the system. And then participant need to insert their carbon consumption data, and the system will calculate the data and then view the result of calculation and plus the recommendation to the user. And then they also can allow to update the carbon consumption, and just the same, it will calculate and then view the result to the user. And then it will also, from the result here, it will also update the leaderboard and then extend to the winner announcement later. And then for the last module, manage system, it just allow to do by MBIP staff or admin. And then next, we go to the package diagram. So we have three package here: view, controller, and model. So view package, it contains leaderboard view, profile view, analysis view, announcement view, and carbon input view. It actually the same with the architecture model that I explained before in the detail. And then it will connect with the controller which is as intermediary with the model, which is contain analysis controller, update data, and then leaderboard controller. And then for the model, it contains user model and carbon footprint model. Which is contain participant and admin data, and then consumption and carbon data and score data. And then this we actually have the detailed description of each model that, as you can see and here. But I will just explain for the overall package class and architecture model here. And then we have the interface of the system here that we design in Figma tools. So this is for the recycle input interface, and then this is for the water input interface. So user need to input their data here, so update, and then it's kind of different here. They need to input the data and the file of the bill here, and update or insert if insert. And then this is for the electricity. It's same with the water. And then this is for the result after their input, all of that. And then this is for the leaderboard winner announcement. So leaderboard like that. And then this is for the rankings of the leaderboard. And then this is for the registration page and this is for the login page. So participant need to insert the username and password that they already registered in the registration page. So I think that's all for me for the phase one, and my teammates will explain further for the next phase. Thank you.
My name is Fathan Muhammad. I want to explain about our works in the second project. So in the second project, we basically will extend the previous class diagram in the project one into uh, into the design pattern. So basically we extend our class diagram with the design pattern, and then first I will explain about the registration and login class diagram. So this is the initial class diagram, and then uh, for the design pattern we use we use builder pattern because it will encapsulate the object, and then the process, and then also the representation of the object. So because the builder pattern is controlled by the software system which is used by user. So user can choose either he or she wants to log in or register, and then and then and then they can choose they want to build their personal details or their environmental design, environmental details such as electricity, water, and so on. And then this is the our second diagram. uh, in the module of calculation we use abstract factory, and then factory method, and then we use uh, iterator design pattern. So why we choose these three types of design pattern? First, uh, so this is the initial, and then this is when we change with the design pattern. So first, this is the abstract factory. So abstract factory will will encapsulate the the class that have similarity, like this is carbon calculation as factory, and then this is the interface or the object of the calculation. So if we want to add more calculation in the future, so uh, we don't change the older version of the code, but just add the new class in here. And then why we choose iterator design pattern? Because we want to search the data, and then uh, retrieve every calculation data for the leaderboard, and find the winner of the carbon competition. So in here we can see this is the object, this is the class, and then this is the list. So by this iterator we will find the data until we get it. So lastly, we have a factory method design method for the view result and recommendation. So factory method uh, is basically is to instantiate new object. So we have in the result and and the recommendation we split by two objects. First is participant result, and then the second is recommendation activity. And then uh, in the winner announcement, we use same with the factory method. So we have in the winner announcement we have three types of object, or we will instantiate this winner object. First is lower carbon winner, second is highest recycle activity, and then lastly higher reduced carbon. So this all for the project 2. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Kemas SDA and my master number is A21EC4047. And I would like to continue what my previous teammates just present. So I would like to explain about the project 3, which starting from the flow-based design and the psychometric complexity. So at the left side of my page right here, I have a flow-based design that we have already designed it for project 3. And we can see here the flow from starting, and the user will be entering the home page. So at the home page, the user will uh, decide which form that they would like to open. So we have three forms. First, we have water form, electrical form, and then um, recycle consumption form. And after they decide which form they want to fill up, the system will generate what they input in the system, and then after that the users can see the result at the another page. So this is a psychometric complexity. We have the 18 edges in the flow-based design, and then 16 vertices and one connected, and then connected components we have one. And then so this is the calculation, and for switch statement the phi is 2, and then the C, which is C, is the psychometric complexity, and our flow based design is 3. So this is our set-based construction. The set-based construction starting from the enter, and then the user will open the form. If the form is incomplete or there is an error during the user form fill, the user or the system will refresh and regenerate the form. If the form is successfully filled, they will be redirected to the user input, and the system will generate the result. So this is the code, and then the entry decision table will be generate this table: IC3 data receive, water data receive, etc. For the C1, if the electricity data and water data are both received, the recycle data is true, and from C5 until the C8 will be false. And then if the water data received from the C1 until C2 will be returned to true. C3 and C4 will turn to false. From C5 to C6 will be turned to true, and the rest will be false. And the rest of the result from the decision table is already shown in this table. So this is the requirement matrix that we already prepared. This is we have the main page. We have use case number 1 and 2, which is login and register page. And then in use case number 3, We have water consumption, where the user just input the water bill into the system, and then you see number three. All of you see number three. We have each of the form like water, electricity, and recycle consumption. And in the UC number five, we have few result which the user can see how the system generate their their bill. So that's all what I can explain about the P3 project, and this is what we all done during the project 3. Thank you very much.
Okay, my name is Tiffa deanara Julius, metric number A21EC4060, and I will explain about the entry decision table and the coding also. So before that, I will explain the coding PHP first for the decision table. So next, function calculate electricity carbon, taking electricity data and then returning it times 0.001. Then for function calculate by carbon, using water data as a parameter, then returning that times 0.002. Then function calculate recycle carbon, taking recycle data as a parameter, then returning a condition. If it is true, then return 100. If it's not, then 200. Then calculate overall carbon using electricity carbon, water carbon, and recycled carbon as the parameters, and then returning all of them added together, then divided by the average. Function determine score and recommendation using overall carbon as the parameter, then assigning score to the overall carbon value, and then recommendation equals to if overall carbon is equal or not equal, is less than 150, it will return good, or otherwise consider reducing consumption into the recommendation, and then it returns it array. So this one is for getting the data for, see, if request method equals post data we get from PHP input, then electricity carbon, if post data equals to electricity, then we will call the function calculate electricity carbon using the post data electricity, and then water carbon. If post data equals to water, then we are going to call the function calculate the carbon using water. Then recycle carbon, if it is recycle, we call the function calculate recycle carbon using post data. Next, for overall carbon, for this one, we call the function calculate overall carbon, electricity carbon, water carbon, and recycle carbon. We calculate the average here and save it to overall carbon. Next, for the results, determine score and recommendation of overall carbon. That's it for the coding. Next, for the decision table, we have 8 conditions. So from here, C1, condition 1, where electricity data is received, water recycle also received. So because of that, we can all calculate electricity, water recycle, true, and then calculate overall carbon and determine score and recommendation. For these two, this one will never return false, because if we see from the code, this all is a condition. If it is electricity, water, and cycle, it will call these methods. If it does not, then it will return 0 for all of them. That is why it will not return false. Also for determine score and recommendation, because it links to calculate overall carbon. So for the condition number 2, if electricity data is received, water data received, but recycle data is not received, then Boolean. I'm sorry, Boolean. it's false. And then, so we calculate electricity, water, and recycled carbon will be false. And the two of these will not change. For condition 3, third condition, we have electricity, we have recycle, but we don't have water. Calculate, so we can only calculate electricity and recycle carbon. This one's the same. C4, we have electricity only, no water, no recycle. So we can only calculate electricity. This one, all the recycle will be false, and this one stays the same. C5, electricity no, water received, and recycle is also true. So for electricity, it's false. This one only, water and recycle only. This one doesn't change. For C6, electricity false, water true, recycle false. So we can only do water, recycle false. This one doesn't change. C7, we don't have electricity, no water, only true for recycle, no electricity, no water, but we cannot do recycle also. This one stays the same. C8, condition 8, all false. We don't have electricity or water data, and recycle data will be also false. Then we cannot do all of it, and recycle will be false also. And then this one still does not change. Next, after the decision table, there are requirements metrics, and that is the end for our project. That is all we're going to present for today, and thank you for listening.